It is possible to create a polygon by detecting the edges of the horizon, such as this common situation where a horizon has been interpreted and holes exist where the faults cut through the surface. Let's take a closer look at the tools that can help here. Right-click and select Create Polygon from Horizon. Give the polygon a name, and once created, change the polygon colour to make it clearly visible. This looks good, but there are some edits required. First, I need to remove the horizon boundary shape that was created along the outline of the horizon where the survey ends. Secondly, I want to reshape one or more of the polygons. Let's zoom in for a closer look. There are too many points in this polygon created by the step effect between the horizon inlines and crosslines. This makes it hard to make a quick edit given how simple this gap appears. If I right-click on the fault polygon in the control panel, I can choose the option to simplify the polygon and reduce the number of nodes by a distance tolerance of 20 meters. Okay, that's done. Let's activate the pencil for the new polygon to show the nodes and change the colour to make it clearly visible. There are much less points now, making any further edits very easy. After zooming back to the previous scale, you can see that all the polygons still follow the shape of the gaps left in the horizon, but have fewer nodes for faster editing. Polygons can also be extracted on filled horizons, where the fault gaps are interpolated. In this case, the steeply dipping interpolations must be isolated, and Horizon Maths is a perfect tool for this. Find an attribute that captures the fault surface. The surface dip might work. Let's find out. Here the steeply dipping faults are shown as a red colour. The faults look a little noisy, so I'm going to run some smoothing on them before creating a polygon. Using Horizon Maths, I can select the horizon dip property as input and use an if statement to check for values above a specified dip. The statement reads, if horizon is greater than 8, then output a 1, else output a 0. After setting appropriate colour values, the fault planes can clearly be seen in bright red colour. The fault planes are a little noisy, and so they can be smoothed along the strike direction of 45 degrees. With the smoothed horizon, I can run the Horizon Maths again, this time setting values above a half to 1 and anything below to a missing number, nan. The missing number creates an edge to the horizon which can be picked up by the polygon generation tool. Right-click and select Create Polygon from Horizon. Give the polygon a name, and once created, change the polygon colour to make it clearly visible. Turning on the interpretation pencil shows that each polygon is made of hundreds of nodes, which will make editing difficult. Using the Simplify function, the polygons can be reduced to a more manageable number of nodes, whilst retaining the same shape. It's possible that the horizons are a little too small if the horizon was not picked cleanly around the fault. In this case, the polygons can be expanded by a fixed amount. Right-click on the polygon name and select Create Polygon from Expand, Contract. Provide a name for the new polygon and set the amount to resize the polygon by. Here I have set 75 meters. Change the polygon colour to make it clearly visible and compare the results to the original polygon and also to the original horizon. That's looking good.
If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.